This is the formula that we use for like story problems for an exponential function. If we have like a virus that's growing, or if we have a population of a city that's maybe growing, or in some cases maybe decaying, this would be kind of the formula that we would use. P sub 0 is the starting amount, whatever the problem is dealing with, right? It could be money, it could be population. There's tons of different instances that we saw when we were in chapter 5 of examples of things that could be going on here. But the reason that we use P sub 0 is if I was looking at data for something, right? And if I said we went all the way back to 1980 collecting data, 1980 would be what we call year 0. That's my starting year. And so we started in 1980, so from there, how many years have passed since 1980, right? And so then I would just count the number of years. But 1980 is our starting. What was the starting amount when we started collecting data in 1980? Okay, K is your rate. I know a lot of times we use R for rate, like on the compound interest formulas that we did, that I put up yesterday. They use R instead of K. Here they use K, but it is the same thing as your R value. Make sure though, if most cases they give us this as a percent, and we have to change it to a decimal. So if it's 8%, we would change it to 0.08. So when you put it into the formula, make sure that you use 0.08. Okay. That was a formula that I gave you in chapter 5, but remember, I'm not giving you any formulas on Monday. Any formulas that you need or want are going to be up to you to put onto your formula sheet. Okay, another thing that I'll tell you too is, like on number 89, when we did chapter 6, there were problems where I would say, okay, let's solve by graphing, let's solve by substitution, let's solve by elimination, and show me the work doing this. Your final is going to be multiple choice, right? So you don't have to show me any work. You don't have to show me substitution. You don't have to show me elimination. You don't even have to graph it if you don't want to. Or if you do graph it, you can just do it in your calculator. You don't have to actually graph it by hand. You don't have to put it onto a piece of graph paper. So like on number 89, you don't necessarily have to graph it by hand. You can just put it in the calculator, tell me where it crosses, and that would be it. Okay? I would also tell you this. On number 89, we have two equations, this system of equations. If it was me and I was solving this, even though it says graphing, solving for y would be one option, okay? But because I don't care what method you do, we could put this in as a matrix, but in order to do that, x, y have to be on the same side, so I need to add 2y to both sides. So I'm going to keep the first question, or the first equation, the same. The second equation would be x plus 2y equals 0. And now you can put it into your calculator, and you can do RREF, okay? So these problems, you can do it any way you want to, okay? You don't have to do the method that it states. That's up to you. Whatever allows you to get to the answer. Good luck, guys. Okay. Just because chapter 6 was fairly recent, and something that I'm going to point out because it was missed a lot when I was grading the test. If you're going to do matrices, if you do a 2 by 3, this is what it should look like, okay? This over here is what RREF should look like, okay? 1, 0, 0, 1. If it doesn't look like this, then I don't have an ordered pair as an answer. If it looks like this, then your answer is an XY ordered pair. It's those two numbers, okay? Same thing for a 3x4. In this case, the RREF, bless you, should look like this. Okay, if the left-hand side looks like this, you have a diagonal of ones with zeros in every other spot, then XYZ is my answer. And we write it as an ordered triple. And I think what happens here is I think we just get in kind of a hurry and we don't necessarily pay attention to the format that the answer is written in our matrix. But here's what happened on the test. And I don't remember what all the numbers were. You had one that was like this, okay? And it was really close, right? And so I had a lot of people tell me the answer is 230 because they just looked over here on the right-hand side and said, oh, there it is, those are my answers. But what's happening here is this is missing a 1 right here. And that's the first indicator to you that something's not right. And I think there was even different numbers in place of these zeros, but I don't remember what it was off the top of my head. So there's probably some other things that are not right about this, but that is the main thing right here, is this bottom row is all zeros right here, okay? So if I see a bottom row of all zeros, that's our infinitely many solutions. Okay, even on a 2x3. I'll see some people do this and they'll say, oh, my answer is 3-1, okay? Because they don't necessarily look at the left-hand side. You have to look at the left-hand side. You have to make sure it looks like these two right here, okay? If it doesn't, here, if we have a whole row of zeros, it's infinitely many. On this one, this would be a no solution. Okay. Because really what I'm saying here is 0 equals 1. This dashed line in here, which your matrix doesn't actually put in, it represents equals. So we're saying 0 equals 1. Well, we know that's not true. Okay. But over here, 0 does equal 0. But it's not a solution. It's just infinitely many solutions. Okay. So you got to understand what your calculator's telling you is the big thing there. Calculators are a great tool. Matrices are pretty nice to solve. But you got to know how the answer is represented there. Here's another situation. I'm just going to make this one up. If I ask you to graph this inequality, okay, can you use your calculator? Yeah, but you'd have to solve for y. Okay, so the way I would go about graphing this is because it's in standard form, I would do the cover-up method. Okay. Do you have to do the cover-up method? No. But that's probably where I would go. I think it's a little bit quicker. And because we're plugging in 0, 0 times 4 is 0. So essentially I have 2x equals 8. So 8 divided by 2 would be 4. Then I plug 0 in for x, but you got to really watch your signs. So when I plug 0 in for x, I have negative 4y. Don't cover up the negative. The negative is in front of the 4. So I have negative 4y is essentially equal to 8. So 8 divided by negative 4 would be negative 2. Make sure you put these two, first of all, on the right axis. Okay, 4, 0 is on the x-axis. 0, negative 2 is on the y-axis. Okay, so we got to get a couple of points. The second thing we got to decide is what kind of sign do I want? Which doesn't have an equal to, so it's going to be a dashed line. If it was equal to, it would be a solid line. So pay attention to dashed versus solid. That was one little mistake that some people made. They put a solid line versus a dashed line, which is different. Okay, and I think the hardest part was where to shade this. Okay, and what we talked about here was pick out a point, and the point that I told you I would always use, if you can, if this line goes through 0, 0, we probably can't use 0, 0. But as long as it doesn't go through 0, 0, I can plug this point in. 2 times 0 is 0. 4 times 0 is 0. 0 minus 0 is still 0. Is 0 less than 8? It is. Okay? And so we would say, yes, this point works. And if we say yes, that it works, then that's the side I want to shade. If I say no, it doesn't work, then I would want to shade down here. Okay? But you got to check it. And here's what happens is some people just look at the sign as less than, and they're like, oh, less than is greater, or is below, so they just shade down here. Okay? The reason why this one is above instead of below is because if I solve this for y, I would end up dividing by a negative, and that's going to flip my sign whenever you multiply or divide by a negative. Okay, so those are all things to just kind of watch, and there's just a lot of little things there to pay attention to. Once again, on the graphing ones, I didn't put a ton of graphing ones on there because, I mean, it's multiple choice, and you got, so if it's multiple choice, they're going to do all the graphs, and you got to choose which one's correct. But one like this, I think there is one like this on the test where you have to graph it, shade it. It's the inequalities that we talked about in chapter 6. Okay, not a lot of things formula-wise to talk about today. Just